Okay, so let's take a look at a quick review of factoring. We're going to break it into three categories. We're going to factor some simple quadratics where the leading coefficient is 1. Then we're going to take a look at using a method called split middle term to factor when the leading coefficient isn't 1. And we might also touch on difference of two squares, which is going to be a third method of factoring. So starting off with the first and kind of easiest method is when the leading coefficient's 1. Quadratic is anything where we have the x squared term involved and no higher degree terms. And the first thing we're going to do is we're going to look at finding a number pair that multiplies to the constant and adds to the coefficient on the x. All right, so a lot of times you'll hear me talking about ax squared plus bx plus c. All right, so c is always going to be the constant, b is always going to be the coefficient on the x, and then the a is always going to be the coefficient on the x squared. So in these first problems, it's going to specifically be when a is 1. All right, so when we look at the first part, we're finding a number pair that multiplies to c and adds to b. So when I look at 6, all right, I've got 1 and 6, which doesn't work. 2 and 3, which does work, because 2 plus 3 gives me the 5. All right. So then when we do this, we set up basically two binomials, all right, so two two-term factors, all right, and in each of them we lead with an x, and that's because x times x gives us x squared, and it would match that first term. Now we're going to take our number pair, and it was positive 2 and positive 3, so we'll go ahead and drop those in. Now we can always check this by doing, we did our first, we can do our outers, that's 3x, our inners, that's 2x, and then our last, and that's a 6. So if we multiply that back out with FOIL, we'd be right back to where we started, so this is our factored form. All right, and again, the big idea is we're looking for that number pair. So in this one, we need numbers that multiply to 7 and add to 8. So if I do 1 and 7, 1 plus 7 equals 8. And we can take and write our factorization, x plus 1 and x plus 7. All right, if I go to this next one, I need something that multiplies to positive 12. So I've got 1 and 12, 2 and 6, 3 and 4. All right, but it needs to add to negative 7. So if I do a negative 3 and a negative 4, all right, those would add to negative 7. So I have x minus 3 and x minus 4. Looking at the next one, I have 18. So factors at 18, we need to add to 7 and multiply to negative 18. So they have to be different signs for the two factors. I've got 1 and 18. That would give me a 17 positive or negative. I've got 2 and 9, which would give me a 7 positive or negative. So 2 and 9, I want it to be a positive 7. So I'm going to keep the 9 positive and make the 2 negative. So I've got x minus 2 and x plus 9. All right, if I look at the next one, we want to find a number pair that multiplies to negative 24 and adds to negative 5. So I got 1 and 24, that would be a plus or minus 23. 2 and 12, that would be a plus or minus 10. 3 and 8, that would be a plus or minus 5. So we're going to do the 3 and the 8. We want it to be a negative 5, so we're going to do a negative on the 8. So I have x plus 3 and x minus 8. All right, and that really is a quick review of factoring when leading coefficient is 1. Makes for a really quick, easy way to factor, and then later it'll be a quick, easy way to solve quadratics. All right, so that's video segment 1. I'll be back with the other two methods.